Hello guys, welcome to another video. In this video, I have done a small POC using Phidata. Like I've just built a small agentic chatbot here. So let's assume it's a customer support chatbot for a trading application. And it has three functionalities. What it does is like it can go through the financial statement and answer any kind of question we ask related to that financial statement. That's the first functionality. And the second functionality is it can return any listed company stock price. If you ask the stock price of Apple, it can return it. If you ask the stock price of Nvidia, it can return. And the third functionality is like it can query the database and fetch the results based on the database schema. So if you see, we have a database here in my PostgreLocal, and it has some kind of columns like what is the trade ID, stocks he purchased, what is the total amount of trading he has done, what is the stocks he holds, what is the overall profit, when is the trade he has done, all this kind of information. A small POC table is there, and this information can also be fetched. So in total, this particular POC is used to do three functionalities. One is to go through the financial statement and fetch the results, and the second is to get the stock price of any company, and the third is based on the columns present in the table, it will be able to answer that as well. So now if you see the flow of this particular chatbot POC, the user will ask a question, and first we have a decider agent, and the decider agent will decide which agent to trigger. And there are three agents. One is to fetch the stock price, and the second is to be able to answer based on the PDF or a financial statement we have provided. And the third thing is based on the question we ask, it formulates the SQL, and it is a team agent here. The first agent will formulate the SQL, and the second agent will execute that SQL in the database, and finally the supervisor agent will convert that SQL output into a natural language. So this is an high level on how this POC works. So now let's go to the code. If you see here, I've just imported the required libraries from Phidata. That's it. And this is my first agent. If you see, to create an agent in Phidata, we have to use this agent class. And what are the argument it takes? What is the name of the agent? And what is the LLM you are using? I'm using OpenAI LLM. And what are the instructions we are going to give to the agent? I'll go through this text. And if you see, the response model equal to decider. So if you see, I'm using the Pydantic Python class here. That's it. And why we are using this Pydantic class? Because I need the response with only three values. This decider agent should respond either with YF or with PDF string or with SQL3. It should not return anything. Just these three values only it has to return. For that, I am going with the Pydantic way. Just I am creating a class and it imports the base model. That's how the Pydantic works in Python. And then it has a variable. And this variable will hold any of these particular three values, YF, PDF or SQL. That's it. So this is how we create an agent, simple agent using Phidata. That's it. This is my decider agent. I just created my first decider agent. That's it. And now we have another class, PDF URL knowledge base, where if we pass this PDF document, it will chunk and store that PDF text information embedded into the vector database. Right now I am using the ChromaDB, which is an in-memory database. Okay, so I'm just using this particular class. I'm passing the PDF link. This is in the same directory, so I just pass the file name alone. That's it. And now what is the vector DB? It has to store this PDF information. That's it. So I got the knowledge base. So now I am creating another agent. As we know, to create an agent, we have to use agent class in Phidata. So I created another agent, and what is the model this agent has to use? So this particular agent should use the knowledge, because we are having the knowledge here, right, in the PDF document. That's what we are saying. Knowledge equal to knowledge base. Knowledge base is nothing but this PDF embedded thing. That's it. And now it has to add the context. Yes, true. And the response should be in the markdown. Yes. And we are giving the instruction to this particular agent. So the major things for to create a simple agent in Phidata is what is the model and the instruction. And all other are optional arguments based on the requirement. If you see for the decider agent, let's check what is the instruction I have given.
When a question is presented, evaluate its context and decide which category it fits into. If the query is about obtaining specific stock information, return YF. If the query involves some content from PDF document, like something needs to be fetched from the quarterly yearly statement, return PDF. If it is meant to query a database, return SQL, because my Pydantic model uses or returns only well among.
So here we are just literally instructing the agent to return only these three values. How is the agent returning only these three values? Using this Pydantic class called decider here. That's it. So in this PDF agent, we are just giving some instruction like
You are a specialized agent with expert knowledge in financial statements. For any query related to financial statement, use only the information available in your knowledge base to provide a clear and accurate response. That's it. We just gave a simple instruction.
now we have another agent, and again to create an agent we use agent class, and then we have the name of the agent, the model it has to use, and here if you see we are using the tool. Above we are using the knowledge base, and here we are using a specific tool, the Y finance tool. Like using this tool we can fetch the stock information, like what is the stock price and all other details related to the stock, what is the max selling price, minimum price for today. All this kind of information can be bought using this particular Y finance tool. Now I'm just giving a simple instruction to is that's it. So this is how we created the financial agent. So till now we have created the decider agent which decides which agent to go, because that's how the workflow is for us. The user question goes to decider agent, it will decide which agent to go. If it's related to a stock price, it goes to this agent. If it's related to financial statement, it goes to this agent. If it has to query something from the database, it goes to this agent. So this is how we created the agents. And now let's see the last agent. If you see, I'm just getting the Postgre connection using this particular module. That's it. I'm just getting the Postgre connection. That's it in my local. And now if you see, I have a method which will just return the metadata information of this particular table. The table name is user traits. That is what the table I have, and this is a table, and this metadata information, what is the column name, data type, and all this kind of information is fetched using this particular method. That's it. If you see, I'm querying the metadata for this particular table, and I'm converting them into the string, appending into a list, and that list I'm converting into a string here. That's it. So now we have another method called execute SQL query. So if you pass a query, it executes that query in the Postgre and returns the response. That's it, as a string format. Again, this is the tool we are going to use. Again, we already know how to use the tools. For this finance agent, it is using the Y finance tools to get the stock price. Similarly, here we have a custom method. And we are using this method as a tool here. So now if you see here, this particular SQL agent, see what is this first agent does. The purpose of this agent is to understand the user query and generate the SQL query based on the user query. So you are an expert SQL query generator using the provided table schema. The schema is nothing but the method which we have, this particular method, right? This method. So based on the schema in this method, we have to generate the SQL query is what we are doing here. The similar way, name of the agent, what is the role of the agent. To instruct the agent or to guide, we have to use two parameters, instruct and role. Okay. And what is the tool it has to use? Get table schema. That's it. So now again we have another agent. This agent will use another tool called execute SQL query. So the first agent will create the SQL query. The second agent will execute that SQL query in the database and fetch the results. If you see, you are an agent designed to receive SQL queries as input, execute them using the provided database tool. Okay, this is the method, execute SQL query method, which we have customly written. That's it. So now these two agents, the SQL generator agent and the fetch result agent, is used in this SQL team agent. If you see, I'm creating an agent and I'm using the name, the model of the agent, the instructions to this agent, and the team equal to this particular two agents which we have created above. So the third in my diagram, if you see, it is a team agent where the multiple agents are working together. Okay. And how they are working together? Using this particular team equal to variable. That's it. The output of this team to the output of these members from this team is passed to this particular agent, and this particular agent will just return that into a natural language. If you finally return a concise and understandable explanation of the result to the user. That's it. If you see, the first use the SQL query generator to create a valid SQL query based on the user request. Then pass the generated SQL query to the SQL result interpreter and execute the query is the second agent, which this does, fetch results agent. And finally convert that response into a human readable natural language. That's what we are saying to this particular agent. So we saw how to create the agent, we saw how to use the storage, we saw how to use the tools, whether it can be the tools which we can import from the modules, or whether it can be a custom tools which we have created. So this is how the basic agent is created in Phidata. Now this is the last piece of code. Okay, what I am doing, I am taking an input from the user. Okay, user will ask some question and I am passing this particular text to this decider agent. If you see this decider agent, what is the decider agent here? The first thing which we have created, this variable. So decider agent dot run of the user query, and the response we are capturing here. And we know the decider agent will return based on this Phidata class with one among these three values, right? So we are just extracting that using. If you see the decider agent response dot content dot who is nothing but this particular variable in this class, right? That's it. That is how we extract the response. So now I am assigning that response to a variable called call. So if the call equal to YF, then I am asking to trigger this particular agent. And if the call equal to PDF, then I am asking to trigger this particular PDF agent. And if the call equal to SQL, I am asking to use this particular SQL team agent, which is the team agents here, right? This one. So now based on that, the specific agent will be triggered based on the decider agent. So the decider agent is deciding which agent to trigger. So now let's try to trigger all those. And I'm just pretty printing here the response. That's it. So now I'll just do run all. It is asking me the question. So I'll just ask what is the stock price of Apple. So now it should return the response. It should return the stock price. See, the stock price of Apple AAPL is $239.07. So it has so the decider agent might have returned the response as YF. So it has used this financial response agent. So now let's try to query something from the PDF. Okay. So now if we go to the preview, let's see what are the macroeconomic and industry risks. Okay. Let's ask this particular question. So now I am just doing the run all. That's it. I'm just asking the question, what are the risks to Apple? Okay, Apple company, because I have the financial statement of Apple. That's it. See, if you see, it has written the macroeconomic risk and industry risk. See, this response we got from this particular document. It has just summarized this whole text. That's it. This complete text it has summarized. That's it. So it has used the second agent. So now let's try to query. Let's try to use the third agent, which is a team agent in Phidata, where there are multiple agents. First agent will generate the SQL and the second agent will query using this particular tool in the database, and this third agent will just summarize the response which we got from this fetch results agent. Okay, so now let's go and see the database once. So now let's try to ask some question based on this particular database. So let's ask what are all the what is the stock purchased by the user for? Let's ask that. It should return HDFC. So let's execute this. User 4. If you see, we got the output. User 4 has purchased the stock HDFC. If we go to the database, we got the same thing. User 4 has recently purchased the stock HDFC. See, that's it. So it has generated the SQL, executed that SQL in the database, and it has responded with the human readable language. That's it. This is how our agent, see, if you see, this is the query it has generated. That's it. So this is how we can create agents or team agents, or create a knowledge base, or we can create a storage, or you can use the tools in Phidata. Just a simple example on how we can create the agent using Phidata. That's it. Thank you so much for watching.